Okay, this is part 2 of the chain rule homework from Unit 2. So in number 3 here, it says you are given an h of x, and that is a product of these two functions here. And it also gives me k, and it says that k is f of x cubed. So that's a function inside a function there. So that kind of leads me to believe I'm going to be using some product rules and some chain rules in there. So in the first one, it says that I'm trying to find the derivative evaluated at 1. So I think it would be helpful to actually, above it, maybe write how I would find the derivative of h. And I'm purposely writing that above because, especially for part B, you'll need a little bit more room than I gave you there, sorry. So I'm just first going to write what the derivative is. So the derivative of h with respect to x, okay, if I was just taking the derivative, this is a product, so it would be first times the derivative of the second, plus the second times the derivative of the first. So I'm just going to write that. So that's first times the derivative of the second, plus the second times the derivative of the first. Well, the derivative of the first is going to be the 2x there. Okay. So now we are just going to plug in 1 for the x values there. So to evaluate this, we'll say that that's going to be, well, if I plugged in a 1, 1 squared is just 1. That part's easy. And then the derivative at f of 1, well, according to this chart up here, the derivative at 1 is negative 2. So I'm just going to multiply that by a negative 2. And then plus f of 1, according to the chart, is 3. And multiply by 2 times, if I plug in a 1 there, is 2. So for this, I'm going to get negative 2 plus 6. So my answer is going to be a positive 4 for my final answer there. Okay. Similarly, when you do this with the second derivative, it's actually going to get pretty yucky. It's going to be really, really long. So I'm actually going to, can I fit it up there? Let's see. I'll write it up here. So the second derivative with respect to x, I'm going to kind of write out the rule for it, and then we'll kind of plug in afterwards. So the second derivative, well, guess what? That means I'm taking the derivative of the derivative. So I'm going to have to do a product rule here, and then another product rule there. So here it's going to be first times the derivative of the second. Well, the derivative of f prime is f double prime, so it's first times the derivative of the second plus the second, which is just f prime, times the derivative of the first. Well, the derivative of that is 2x. So that takes care of the first chunk. Now I need to go ahead and work on this next chunk. So I'm going to have to use product rule there again. So from there we have first times the derivative of the second, so it's first times the derivative of the second, which is just 2, plus the second, which is 2x, times the derivative of the first, which is just going to be f prime of x. Okay, so now for this h double prime here, I'm going to plug in a 1 for all of those things. So when I plug that in, 1 squared is just 1. Then when I plug in a 1 here, that's f double prime of 1 is 2 according to this, plus f prime of 1 is going to be a negative 2. And when I plug in a 1 there, I just get 2. So now I'm over in this section here. If I plug in a 1 there, f of 1 according to this is a 3. That's plus a 3. Close parentheses, or now start a new parenthesis. So that was a 3, and multiply that by a 2. Plus, when I plug in a 1 there, I just get a 2. And then when I plug in there, I get a negative 2. So hopefully I plugged all that in. That gives me 2 minus 4 plus 6 and a minus 4 again. Okay, so then you can add all those together. Oh, and that just gives me a 0. So I have a 0 there. Okay. Very similarly, you can kind of work out the other two, okay, and I can provide you with those answers there. Hopefully I did them correctly. So for this first one, if you work it out, I got an answer of -6. And for this part D over here, when I worked it out, I got the answer of +6. Okay, so you could try those. This time when you're doing it, you're going to have to use the chain rule, okay, because you have a function within a function, but it's similar to the others, so you could practice those. Okay. All right. At what point on the graph of y equals square root of 2x minus 3 is there a vertical tangent line? So, vertical tangent lines. You should kind of be thinking to yourself that there is a vertical tangent line, okay? You should be thinking the denominator is 0, right? So slope of the tangent line, you're thinking slope. Slope in calculus means derivative. So really what this is saying is take a derivative, and then you're probably going to end up with some sort of a denominator, because that's how you're going to get a vertical tangent line there. So we're going to take a derivative and then set the denominator of that derivative equal to 0. So that's our goal. So first what I'm going to do is recopy or kind of rewrite the original. Again, when I see a square root, I'm automatically thinking of that as to the 1/2 power. And now I can take the derivative of that. The derivative of that. Let's see, so that's going to be a chain rule, so that's 1/2. 2x minus 3, subtract 1 from the exponent, gives me -1/2, times the derivative of the inside, which is just a 2. And this 1/2 and that 2 are going to kill each other off. So I have the derivative of being 1 over the square root of 2x minus 3. Sorry, that got a little bit squished. Okay, and so we are going to set that. So the vertical tangent line, you should be thinking set denominator equal to 0. So this, okay, we're going to set that equal to 0. Square both sides, and then subtract 3. So you get this, and then I got x is going to be 3 over 2. So that's going to be the x value. And then we make sure we are answering the full question. It says a point. If I just give an x value, that is not a point. So make sure you go back and find the y value. And so you can find the y value by plugging in to the original. So 3 minus 3, right? Because if you do 2 times this, it just gives you 3. So 3 minus 3 is 0. The square root of 0 is 0. So the point would be 3 over 2, comma, 0. And we got that one done. All right, moving right along. So 5, find the equation of the tangent line to this graph at the point. Oh, so this is nice because they gave us the x value and the y value of the point. Okay, and the equation of the tangent line, when you see equation of the tangent line, you should be thinking take a derivative, then use the point slope formula. So I'm going to take the derivative and then use the point slope formula. So the derivative, all right, so the derivative of e to the whatever is, you recopy the entire thing, then you just take the derivative of the exponent. So if you kind of recopy the entire thing, okay, just how it is, and then you multiply that by the derivative of whatever the exponent is. So the derivative of that is 2. And of course, yes, you can clean that up into -4e raised to the 2x there. So we've got that as our derivative. Okay, so that's what our y prime is. Now we're going to evaluate that y prime at x equals 0, because that's what was given. So to denote that, you'd say y prime of 0. So if I plug in 0 for x, 0 times 2 is 0. So we are saying this is e to the 0. And hopefully remember that anything raised to the 0 is 1. So there you just get a -4 for the slope. And we are answering the full question, so we need to write the equation. So again, you're going back to y minus y1. Well, it's y minus a negative turns to a plus, equals m. The m I solved for was over there, that -4. So -4 parentheses x minus x1 is 0. If it is a free response, you're going to leave it like there. It's your safe stop. If it is a multiple choice, they will probably have them foiled and written out like this. So there's your answer there. Okay. The next one, okay, Remember that the secant line is an approximation to the derivative, and the secant line has 2 points. If there is 2 points, you can calculate the slope, just like you did back in the day. So let's see. So estimate the rate at which the child is growing. So estimate tells me I'm going to be able to use the squiggly instead of the equal sign. So I'm really trying to figure out the derivative at 11. So h, I'll call that h for height, right? At 11 is approximately, this is an approximation. So we're just going to use, if you realize 11 falls right here, so that means that this the 10 and the 12, and those are going to be important. So basically it's h of 12 minus h of 10 all over 12 minus 10 there. And you can go ahead and grab all that info from the table. Over 2. And I think that ends up to be 6.5 if you type that in correctly. Okay. So there you are. There's the approximation. Okay, and for those of you that kind of hung with me, I wanted to go back and kind of show you those answers after you had a chance to work them out. What I did for k prime and k double prime over here, I actually kind of worked out this is what the derivative is in the terms, and then this is me plugging it in. And for k double prime, I actually worked it out up here what it should be so that it wasn't so squished. And then I plugged it in for you down there. So feel free to pause the video at this time if you need to kind of pause to check your work. And then also at the very bottom, I also included the answer there. So, all right, have a great day, and I'll see you in class. Bye-bye.